Hi all, I am Dr. N. Maithili, Professor, Department of Computer Science and Engineering, St. Joseph's Institute of Technology. Today I am going to handle the topic 2D transformations. When you have an object in a digital monitor is a rectangular array of rectangular matrix, consists of so many rectangular grids. Each rectangular grid contains a pixel. Pixel is nothing but a picture element. Okay. When you have an object or when you draw an image in a digital monitor, we are plotting the pixel in all the places where we want to have the image or object, right? So the collection of pixels is called an object, right? And when you talk about transformation changes in size, shape and orientation of the object is accomplished with transformation. So that is the definition of transformation. And the transformation makes the change in coordinate descriptions of the object. Okay, right. So when you want to do any transformation or any magic, so we have an object in our digital monitor, right? So you can do any kind of magic with the object. You can make the movement of the object, you can change the size of the object, you can enlarge the size of the object, you can reduce the size of the object, and you can rotate the object. Whatever magic you want, you can do with the object on your digital monitor. Okay. So when you want to do all these magics with the object, what shall we do? We cannot do any transformation or we cannot give any instruction to the computer to do the particular transformation with the object fully. So any instruction consists of an equation, right? So logic, we are using some logic to do any action in the digital monitor. So that logic is an equation, right? The equation is nothing but and also we cannot give the whole equation to the computer because the computer cannot understand the whole equation. So in what way all the instructions are stored in a computer is it is in the form of zeros and ones, and also all the zeros and ones are stored in the form of matrix. So when you give an equation, the equation is not straightly given to the computer, it is given in the form of matrix to the computer, right? Okay. So we are going to derive the equation for all the transformations, and we are going to represent matrices for all the equations, right? Now the types of transformation. What are the types of transformations? Number 1, translation. Number 2, rotation. Number 3, scaling. Number 4, reflection. Number 5, shear. So there are 5 types of transformations which are available. So among all these 5, the first 3 are basic transformations: translation, rotation and scaling. Okay. So we will see the transformations one by one. Now the first one is translation. Okay, what do you mean by translation? Translation. So first definition of translation. Translation is nothing but repositioning an object along a straight line path from one coordinate position to another coordinate position. So when you do translation, we will have the change of coordinate description from one position to another position, right? Okay. Let us see the translation process. Okay. Now this is a 2D plane because we are talking about the transformations which are happening in 2-dimensional plane only. We are not talking about 3-dimensional plane. We are talking about 2-dimensional plane only. Okay. Now this is x-axis. and this is y axis. Since we have only two axes, it is called two-dimensional plane, right? Okay. Now the object, as I told you already, we cannot apply the equation to the whole object. We can apply the object to a single pixel, right? So when you apply the equation to all the pixels, then all the pixels are transformed to some other position, so that you will have the object that is moved to some other place, right? Now here the object I have taken is a point, right? So the point is nothing but a pixel. Pixel is picture element, okay. Let us name this point as P, okay. Now the spatial location, the coordinate position of this pixel P or the point P is x comma y. Okay, now the transformed position or the translated position of this same point P is named as P dash, and the new spatial location is x dash comma y dash. Okay. Now this point P is translated to some other point P dash along a straight line path. So that is called translation. Okay. Next. We are going to write translation equation for this translation of a point P, right? The translation equation is x dash is equal to x plus tx, y dash is equal to y plus ty. Okay, where x comma y is the original coordinate position. X comma y is the original coordinate position. X dash comma y dash is new coordinate position. Tx comma ty are translation distances or translation vector. Translation distances or translation vector or shift vector. Okay, now this is the translation equation, right? Okay. Now the next one is rigid body transformation. Translation is also said to be rigid body transformation. Why? Because so when you apply the translation equation to an object, we have the transformation without any deformation. That is, we won't have any change in size and shape of the object. Okay, so that's why the translation is also said to be rigid body transformation. Next, types of translation. The first one is straight line translation. So when you let us assume a line starting from this point to this point, and in graphics we are assuming that we are having a line in between these two pixels, but it is not so, right? So actually how the line is drawn between the two n coordinates, the system will plot the pixels in between the two n coordinates, the nearby pixels. So when you combine all the nearby pixels, you will have the line, right? But for the translation, so when you redraw the line to some other position, we have to apply the translation equation to all the points in between these two points. Then only you will have the points in some other position, right? But there is no need to do, or there is no need to apply the translation equation to all the pixels of the line. What shall we do is, we can apply the translation equation only to the n coordinates, and the line can be redrawn between these two n coordinates using line drawing algorithm. So the translation equation is applied only to the n coordinates. So we are applying only 2 times for straight line. Next one, polygon. So as in the case of a straight line, we are having the same that is applied to polygon. So polygon, how the polygon usually drawn is, suppose if it is this polygon is, a polygon is constructed in between the end vertices, right? So when you apply translation to a polygon, we can apply the translation equation only to the end vertices of the polygon, and so that we will have new end vertices, right? And we will have the new polygon that is reconstructed between the new end vertices. Okay, so in the case of circle, suppose here we have a circle, right? How a circle is generated using the one coordinate position means the center coordinate of the circle is plotted and the circle is drawn with the center coordinate using circle drawing algorithm. So in the same case, for translation equation, we can apply the translation equation only to the center coordinate, and we will have the new center coordinate, and we can have the circle by using circle drawing algorithms with the new center coordinate. There is no need to plot the pixels over the whole circle. Okay. So this is types of translation. Next one, matrix representation. Matrix representation. In matrix representation, so here we have the equation, translation equation, and when you convert this translation equation into matrix form, here the coordinate descriptions are 3 element column vectors. So here x dash y dash 1 is equal to here x into 1, right? Y we don't have any y value, so 0, and constant is tx. Here we don't have any x value, here y into 1, constant ty, and for 1 0 0 1 into x y 1. So when you multiply here, first row first column, so x dash is equal to first row first column, x dash is equal to 1 into x plus 0 into y plus tx into 1. So x plus tx. Next, y dash is equal to 0 into x, second row first column, so 0 into x 0 plus 1 into y, y plus ty into 1 ty, so y plus ty. Okay. The abbreviated form, next, the abbreviated form is P dash is equal to abbreviated form, okay. P dash is equal to T of Tx comma Ty into P, right? And the next one, composite transformation. Composite transformation. So composite transformation is nothing but we are having one object, right? And we are going to apply the translation equation to the object with some translation distance. So you will have the object to be moved to some other place, and again we want to apply another translation equation with some other translation distance to the transformed object. So 2 times we are applying the translation equation, but here in the case of translation, no need to apply to the translation equation 2 times to the object. What we can do is, we are having 2 translation distances, right? So we can concatenate the translation distance, we can composite the translation distance together, and we can have a single translation distance, okay? Then we can apply it to the object, so that we can apply the translation equation only once, right? So T of Tx1 Ty1 Tx2 Ty2 into T of Tx1 Ty1 into P. Okay, so this can be written as t of tx1 comma ty1 into t of tx2 comma ty2 into p. So this can be written as now composite transformation matrix is 1 0 tx1 0 1 ty1 0 0 1 into 1 0 tx2 0 1 ty2 0 0 1, which is equal to 1 0 1 0 tx1 plus tx2 0 1 ty1 plus ty2 0 0 1. Okay, so when you multiply these two things, we will have t of tx1 plus tx2 comma ty1 plus ty2 into p. So this indicates the composite transformation or the successive translations are additive. Okay, so this is what about translation. I hope you understand the full concept of translation. In translation, what we have seen is actually the definition of translation and the translation equation and rigid body transformation, types of translations, matrix representation of translation and the composite transformation, right? Okay, the next type of transformation is rotation. Okay, now the next type of transformation is rotation. So what do you mean by rotation? First definition. Okay, what is rotation? Rotation is also repositioning an object from one coordinate position to another coordinate position along a circular path. In the translation, we have seen straight line path, but in the case of rotation, it is in the circular path. Okay, that is the only difference. And what are the things needed for having rotation is things to be specified. Number one, rotation angle theta. Rotation angle theta. Number two, rotation point. Rotation point. Number three, rotation axis. Rotation angle theta is the angular position of the point with respect to coordinate origin. Rotation point is nothing but the point about which the object is to be rotated, and rotation axis is nothing but the axis about which the object is to be rotated. Okay, and if you give positive values to rotation angle, you will have the rotation in counterclockwise direction. Suppose if you give negative values to the rotation angle theta, you will have the rotation in clockwise direction, right? Now next the rotation equation, we are having two cases. Okay, the first case is rotation of a point. The object we have taken here also is a point. Okay, now rotation of what is the first case is rotation of a point or object from x comma y to x dash comma y dash with respect to coordinate origin. With respect to coordinate origin. So for this case, let me explain with the diagram. Okay, so now we have the axis, right, and we have both are in the same distance. Now this is the original point P. The spatial location or the coordinate position of the point P is x comma y. Now this is the transformed point with the coordinate position x dash comma y dash. Okay. Now here the distance is x and now this distance is y and this distance is x dash. This distance is y dash and now this hypotenuse distance is r. Okay. Now so from this diagram now we have only 2 points. One is the original point and the other one is transformed point, and I am making the triangle over these 2 points, right, to derive the rotation equation. Okay. Now here the angular position is pi and here the angular position is theta, right. Now here we have for this triangle, let me take this as a triangle. Okay. So for this cos pi is equal to adjacent side by hypotenuse side. Okay. So adjacent side is x, hypotenuse distance is r. So x by r. So when you cross multiply, you will have x is equal to r cos pi. Right? So cos pi is adjacent side by hypotenuse. Hypotenuse distance we are taking it as r. In the same way, when you take sin pi, that is opposite side by hypotenuse. Opposite side, sin pi opposite side is y and hypotenuse is r, which implies y is equal to r sin pi. Okay. So when you take this triangle, so let me take this triangle, and for this triangle cos of pi plus theta is equal to, so this cos of pi plus theta is equal to adjacent side by hypotenuse. So here the adjacent side is x dash, hypotenuse is r. So when you cross multiply, x dash is equal to r cos pi plus theta. Okay, so cos of a plus b is cos a cos b minus sin a sin b. So r of cos pi cos theta minus sin pi sin theta. Cos a cos b minus sin a sin b. So when you multiply this, r cos pi cos theta minus r sin pi sin theta x dash. Now here r cos pi is equal to x, r sin pi is equal to y. So when you replace this with x and this with y, x dash is equal to x cos theta minus y sin theta. So in the same way, we can take sin of pi plus theta is equal to opposite side by hypotenuse. So for this triangle, sin of pi plus theta is equal to opposite side is y dash, hypotenuse is r. So when you cross multiply, y dash is equal to r sin of pi plus theta, which is equal to sin of a plus b is sin a cos b plus cos a sin b. So r sin a cos b plus cos a sin b. So when you replace r sin pi with y, r cos pi with x, y cos theta plus x sin theta. So let me repeat it, x sin theta plus y cos theta. This is y dash. So we have derived the two equations, x dash is equal to x cos theta minus y sin theta, y dash is equal to x sin theta plus y cos theta. Okay. So when you write the equation for this, actually P dash is equal to R into P, where R is equal to cos theta minus sin theta cos theta. Okay. Hope you understand the rotation equation. So this is the rotation equation for x dash for new coordinate point. The transformed rotation point of x dash is x cos theta minus y sin theta, and for y dash is x sin theta plus y cos theta, right? Okay, now we are going to write the matrix representation for this. So the matrix representation is x dash y dash 1 is equal to cos theta minus sin theta 0, sin theta cos theta 0, 0, 0, 1 into xy1. Okay, right. So this is a matrix representation, and in the abbreviated form p dash is equal to r of theta into p, where theta is the rotation parameter and r of theta is rotation transformation operator. Okay, so and also coming to composites, and also in the same way rotation is also called rigid body transformation, and here also we are having types of rotation, straight line rotation, circle rotation, ellipse rotation, everything. In the ellipse rotation, the rotation is done with respect to the center coordinate and also with respect to minor axis and major axis, right? Okay, coming to composite transformation, in the same way rotation equation, the first rotation equation is applied to the object, and the second rotation equation will be applied to the transformed object. Instead of that, we can concatenate the two rotation equations together, and we are applying only once to the object. Okay, so we are having r of theta 1 into p, right? Here r of theta 2 p dash, which is equal to r of theta 1 into r of theta 2 into p, which is equal to r of theta 1 plus theta 2 into p. This is the composite transformation for rotation. So here also it tells the rotation parameters are the successive rotations are additive. So this is what about rotation. And also we have another case, rotation of a point from xy to x dash y dash with respect to the point xr comma yr. So we have the second case. So actually the rotation equation is x dash is equal to x cos theta minus y sin theta, y dash is equal to sin theta plus y cos theta. So when you take the second case, the diagram is redrawn. So this is xr comma yr with the same parameters. So we are converting these two equations with respect to the point, not with respect to coordinate origin, and we are having rotation point xr comma yr. So x dash is equal to, here we are adding this xr and this x. Now here the x is so this point, this particular distance alone must be taken. Now here in this case x is the whole value. So now here we need this place alone. This is xr. So the xr should be subtracted from the whole x. So instead of x, you must have x minus xr into cos theta, and in the case of y, so the whole is y, this part should be subtracted yr. So y minus yr into sin theta. Okay, so in the same case y dash is equal to yr plus x minus xr into sin theta plus y minus yr into cos theta. So this is the second case, the rotation of a point from xy to x dash y dash with respect to a point xr comma yr, not with respect to coordinate origin, right? Okay, so with this rotation is over. Okay, the next type of transformation is scaling. Okay, scaling, the definition for scaling is scaling alters the size and shape of the object. Okay, so when you apply the scaling equation to an object, you can enlarge the object, or you can reduce the size of the object, or you can change the shape of the object, right? Now the scaling equation x dash is equal to x into sx, y dash is equal to y into sy, where x and y are original coordinates, x dash and y dash are new coordinates, sx and sy are scaling factors. Now this sx is nothing but a scaling factor which scales the object in the x direction, and sy is the scaling factor which scales the object in the y direction. Okay, right. Now based on the scaling factors we have many cases, right. Case 1, when sx and sy both are greater than 1. So when the scaling factors, when the value of the scaling factors are greater than 1, we can have the enlargement in the size of the object. Okay, and also we can have the object which moves far away from the coordinate origin. Suppose if you have the object here, and when you apply the scaling equation to the object, and if the scaling factors are greater than 1, you will have the object which is moved here, right. And the second case is sx and sy less than 1. So when both the scaling factor values are less than 1, you will have the object to be moved closer to the coordinate origin, one thing, and also you will have the size, you can have the size of the object to be reduced after applying this scaling equation to the object with the scaling factors less than 1. Okay. The third case is sx and sy equal to 1. So whenever the scaling factors, both the values of scaling factors are equal to 1, you won't have any change in size and shape of the object, right. So you will have the same coordinate position. When you multiply the original coordinate position with the value of 1, you will have the same value. So we won't have any change in size and shape of the object. And the fourth case is sx and sy if both are equal. Suppose if you have the value for sx is 4 and sy also 4, you will have the relative proportion size in the object. Okay. So we have change in the relative proportion of the original object, right. Suppose if you have square, you will have the square shape only with the enlargement, right. And the fifth case is, if suppose you have unequal values of sx and sy, you will have change in shape of the object. Suppose if you have square, after transformation you can have rectangle, right. Now the transformation, matrix transformation or matrix representation. So what is the matrix representation in 3-dimensional way is x dash y dash 1 is equal to sx 0 0 0 sy 0 0 0 1 into xy 1, right. So in the abbreviated form, p dash is equal to s of sx comma sy into p, right. So for the composite transformation, sx1 0 0 0 sy1 0 0 0 1 and sx2 0 0 0 sy2 0 0 0 1, which is equal to, we will have sx1 into sx2 0 0 0 sy1 into sy2 0 0 0 1. Okay. So it denotes the successive scaling operations are multiplicative. Okay. So these are the 3 basic transformations: translation, rotation and scaling. Okay. And reflection and shear are the other 2 transformation. Suppose if time permits, I'll take it in the next episode. Thank you all. Hope you all understand all the 3 types of basic transformation in detail. Thank you.